So I hope the screen is visible now.
Yes, it's visible.
Okay, thank you. Okay, so as I mean, morning session was very interesting, and Professor R.P. Saini gave a lot of basic concepts and also some of the applied concepts related to different solar energy systems. A bulk of his lecture was focused on solar thermal systems, and then also in brief, he covered the solar PV systems as well. So that is also interesting because I think that will diversify the coverage, because his lecture being more focused on solar thermal, now we'll be focusing more on solar PV. And as we all are aware that PV is these days the most popular application of solar energy, and it finds several interesting applications, and it all started with as we all know, in 1960s and all. Around that time, people started thinking of having solar PV cells or solar PV panels, as we say, for some of the extraterrestrial applications, the satellite, the space vehicles and satellites and things like that. So basically for satellites which are operating, orbiting around the Earth. So initially it started from there, and the success which it gathered, I mean, one of the initial tests which they did, I mean, 2 different satellites were launched somewhere in late 1950s or early 1960s. One of them with the conventional batteries, and another one with solar cell powered satellite. So what they found was that this solar cell powered satellite actually lasted way longer than the conventional battery thing, and that actually spooked the interest. So that's how it started. The application of solar PV started in 1950s and 60s, early times. But then, and for some time, that was the only application which people were thinking of in terms of the PV. But gradually, as things evolved, and 1970s, we know there was this major oil crisis, and people started thinking of alternative sources of energy. And gradually further, as 1990s and all set up, they started, and there was this attention of people came towards climate change and other such issues. So gradually, as renewable energy started becoming more and more prominent, then 1990s actually is the period when solar PV actually started finding a lot of ground applications. I mean, 70s and 80s also saw few applications, but 1990s was like a major opening era for solar PV in US and Europe. And then in India, we are seeing for last 10 years or so, there has been a huge boom in solar PV. And that started with the 2010 National Solar Mission, which was further upgraded to, the capacity, the envisaged target was revised, and it was made 5 times of the initial target in 2015. So gradually, we see that solar PV has become really prominent. And these days, if you look at the data of last 2-3 years in terms of the global capacity additions across different technology options, what we see is that PV is actually having a major chunk in the capacity additions. In fact, now the renewable energy additions are more than the conventional power plant additions. So that way, it's very important and pertinent, and very, very relevant also for present times. So how I've organized this, as we know, there are these 2 sessions. One is this one from 11:30 to 1, and next one is 2:30 to 4. And though as we look at the timetable, we have mentioned like one as the conceptual, another as the application thing. But because of the nature of the thing, it will be a mixed one. So we will do it in parallel. And as we go ahead and keep on discussing the things, we'll also keep on implementing it. So we'll be focusing entirely on solar PV in these 2 sessions. And in solar PV, we will be talking about we'll be like doing the both the theoretical aspects of the modeling and simulation, as well as the hands-on part in parallel. And how we will divide is that, like in the first session, we hope to complete the standalone PV systems. And then in the next session, we will be focusing on the grid connected PV systems. So that will be the flow of these 2 talks, these 2 sessions. So with that background, let's start. And right now we will start with the discussion on the standalone PV systems, and we'll see some of the ways in which we can model them. So this entire thing we will, as I had announced yesterday also, that the software tool we will be using for our implementation and hands-on modeling will be PVSyst. So that will be the thing, and I hope everyone has downloaded PVSyst and has installed it. So because we'll be referring to it on and off again and again, and as we go ahead. So looking at some of the basics, I mean, the standalone PV systems, as we understand that they are always organized around a battery storage, because here there is no grid connection. So you have the PV panels which are generating the power, and then you have some loads at the premises which need to be supplied that power. But then, as we understand, that sun is only available for a few hours in the day. So intrinsically, this standalone PV system will always come with a battery storage. And the PV array charges the battery or directly delivers its power to the user. So when the sun is up and the PV power is available, then ideally we would like to route it directly to the user, and whatever is the excess which is beyond the user's consumption, then that can be saved in the and stored in the battery. So the user's needs or consumption should be well defined with its daily profile. That is one thing we look at it, that when we talk about the standalone PV system design and modeling and simulation, the user's need is a prominent component of that, and it needs to be very clearly defined. So the simulation, when we talk about the modeling and simulation of this type of a PV system, what we are mainly talking about is the the power balance, or the balance between the PV production, which is depending on the irradiance, and the user's needs on an hourly basis. I mean, that is same for every power source, as you understand, because the balancing between generation and load is what is about this the entire thing of power generation. So here also we will be looking at this, and the one thing is that as we understand, because there are these three players. One is your PV power PV panel, which is generating the power, the PV array, so to say, because it will be usually a set of installations panels. So one is the PV array, then you have the load, and third is the battery. So there is an interplay between these three, and whenever whatever is the excess which is not being consumed by the load, that can be supplied to the battery. And in the other case is that when the PV panel is not available, when the either maybe sometimes due to some particular fault, but not so commonly, but mainly due to the time, the non-sunshine hours after the sunset, or even during the early morning or late evening hours, even when the sun irradiation is low, then the PV output might not be sufficient to meet the user's needs. So during that time, the battery will be having a negative power input. That means it will be supplying the load. So this energy balance, the flow of energy between these three players, the PV generating system, the PV panel, and the load and the battery, this needs to be controlled by a controller. And this controller is tasked with the task of handling the energy flow. And one of the important criteria is the protection of the battery, because as we understand, the battery is having a critical zone of operation in which it can perform in a good way. And basically the level of discharge, or which we call as the depth of discharge, is something very critical for the battery operation, and that should be monitored. So controller will have that particular task of appropriately monitoring the operation of the entire system, so that the battery's depth of discharge doesn't go below whatever is the specified level. So there are two prominent operations we can, I mean, in a broad way, if we speak at a very preliminary level, then the controller will have these two operations. One is that when the battery is full, the PV array should be disconnected. So, because if it's full to its capacity, you can't really pump in more power. So that is one thing. And another thing is that when the battery is empty, the user should be disconnected. So that is also obvious that, I mean, not really empty, the word rather, I mean, if you look at it, because this is like sort of just a general thing, but if you look at it in technical terms, we would say that when the battery's state of charge is below the depth of discharge, acceptable level of depth of discharge, then the user should be disconnected. And some other functions might also be there for the controller. So if you want to have a fully automated system and with some backup option as well, so suppose you have some backup generator, a genset which is available at the premises, and you want to fully automate the thing, then your controller should come with the capability that it should be able to sense that when your battery plus PV setup is not able to satisfy or meet the load demand, then it should activate the or put on the backup generator or the genset. So that would be like a really fully automated system. But I mean, that is more of a luxury, you can say, in many cases. Typically, that can be that type of automation might not be needed or might not be available in the given cost constraints or all. So those things are there. So looking at now we'll look at three types of standalone PV systems depending upon their size. So this first one we are looking at is the small standalone PV system of small power rating. And this thing is, is the most simplest one. And as you can see here, as we described the three elements, you have the PV array and you have the battery and you have the user or the load. And the controller is what is controlling the energy flow across this entire system. So when you have PV generation available, then these switches are closed and the power generated from the PV panel is being supplied to the user. If there is an excess, it is being supplied to the battery. And same way, if the load is higher and the power generated is low due to low irradiation or something of that sort, then the battery will discharge and supply the load, fulfill that particular balance. And when if we want to have the operation for the entire day during the non-sunshine hours, so that time the PV array is not available and the battery is what is supplying the user load entirely. And also, as we discussed, that when the battery charging is full, and then also we need to disconnect the PV array because we don't want to pump more power here. Or if the battery's state of charge is below the depth of discharge, then we need to disconnect the user so that it doesn't draw more power from the battery. So those are few of the possible operations, and the controller will be having this task of dealing with these particular energy flow and balances. So this type of small system and the simplistic block diagram which we just now looked at, this is really applicable only for small systems, typically in the range of 50 to 200 watt peak, having a very limited consumption. Typically only the DC loads, like some examples like lights, radio, TV, computer, and no heavy loads like AC and fridge are not there. This thing is also known as a solar home system, or SHS sometimes in short, and this might be useful for a very small home, or maybe for a rural area where there are no very complicated loads, only simple lighting, or at most the TV load and fan load is there. So that type of things. And with these simple systems, the PV array, one or few modules is usually connected directly to the battery without power conditioning. This implies that the PV modules should be 12 volt or 24 volt modules, that is with 36 or 72 cells. So as we said, this is a very simple system, and we are talking about basically sort of all the DC loads which are there in the system. So that's why we don't need the power conditioning, and the PV array is directly connected to the battery and the loads. And this type of installation is managed with simple controllers acting either by disconnecting the battery or short circuiting the PV modules when the battery is full. So that we already discussed. And these controllers have the ability of controlling the load when the battery is empty. So as we can see, the controller has a particular tab on the load also. So if the battery is below the depth of discharge permitted level, then this load will also need to be disconnected. So really a very simple and a small system, not having a very wide application, but only for maybe some very remote locations, small houses, and typically in rural areas and all, this might be used. Then a little more advanced system is this one, which we can call as the medium-sized standalone PV system. And here, as you can see, compared to the previous system, there are few more complications which have been introduced. So you have now this controller is coming with this type of an MPPT converter. As we understand, this MPPT feature is very important when we talk about the solar PV systems. MPPT stands for the maximum power point tracking. And as we understand, and it was discussed in the last session also by Professor Saini, that there is a particular IV characteristic which is there. This sort of, if you plot the current on the your y-axis and voltage on the x-axis, then it's like initially a drooping characteristic with a slight droop, and then there is a knee point after which there is it just tapers off. The slope is very sharp. So that type of IV characteristic is always there for any PV system, PV panel or array. Now we understand that in this system, because we know the power output of this PV setup is basically the voltage into the current. And if I want to maximize the power output, I need to, it's quite simple and everyone knows basically that the knee point, or where the curvature is suddenly changing, that particular point, the knee point, will be the maximum power point, where you can have the area within that particular rectangle between the x and y axis and this particular operating point. That rectangle will have the maximum area. So that type of thing we understand, and that's why all these larger PV systems, typically the medium sized, even, this is also very small, larger in context of the previous system we are seeing. So any significantly sized system will usually come with this maximum power point tracking, because we need to ensure that your power output is at the maximum level in a given irradiation condition. So because as we know, when the irradiation changes, then this IV characteristic also shifts up or down. If the irradiation goes up, the same IV characteristic will shift upwards, having a higher current output possibility, and if irradiation is going down, it will shift down. So accordingly, this MPPT tracking is continuously trying to keep the operating point of the PV system in terms of the voltage and current at near the maximum power point. So for a medium-sized system, this MPPT converter becomes recommended, and along with that, as you see, there is another optional backup or a genset which is here, and this also has a link with the controller. As we said, if we want to automate the entire system, then the controller should have control on the optional backup also, and in case your PV and battery system is not able to meet the user loads, then this backup can be put into operation. So these systems, usually these medium-sized systems, when we talk about, they also, as you can see, are very small systems really, and only for residential applications. Typically, they have range of power range between 200 watt peak to around 2 kilowatt peak. And these also can be used typically for small household or maybe communication applications. If you have some, usually the bigger communication towers also will have a larger power range, but if you have some smaller communication application of that sort, it might be used. So this controller includes a power conditioning unit able to perform the maximum power point tracking on the PV array. So this we have discussed already. Therefore, the PV array voltage is no longer related to the battery pack voltage. So we are not fixing the PV array operational voltage at the battery level, because for the smallest systems, it was not really cost effective to have that type of MPPT mechanism, and we can just peg the PV voltage to be at the battery voltage level only. But as the system size increases, the losses which will incur in the overall system efficiency due to that type of fixed voltage will not really be acceptable. So for any significantly sized system like this one, we have this MPPT, which will come usually with a DC-DC converter, because as we understand, battery also needs a steady voltage for charging. And now you have MPPT, so your PV voltage and current will be fluctuating depending upon the irradiation and temperature conditions. So this MPPT along with the converter will ensure that your battery system is also getting power at its designated voltage level, and the advantage of maximum power point tracking is also being captured here. So in this case, therefore we said that this will come enabled with the power point tracking and some sort of power conditioning unit. And the most of the time the controller is also able to ensure the load control, because again that aspect also has to be there in case, because you don't want to drain your battery completely. So that type of user load control should also be there. And the energy may be used as DC energy or fed as AC energy through an inverter. So that will depend upon the type of loads. So if you only have the DC loads, then you will not need an inverter. Only this DC-DC converter would be needed for interfacing the PV array with MPPT and the battery. And in case the loads are AC as well, then as we understand, because this will be a DC output until the battery thing. So if I want to have a load which is having AC power requirement, then we need to have an inverter somewhere here so that this can convert the DC output of the PV or the battery to the appropriate form for the load. So that can also may or may not be needed depending upon the type of loads. So these installations may power lighting, fridges, washing machines, dishwashers, small electro tools, etc. And these may be used in some small remote communication systems as well, stations as well. So not really for big communication towers and all, but if there is a smaller remote communication station that might fall in this particular power range, then this type of a setup might be used for those systems also, and for small households as we discussed. And such systems may rarely be supported by a backup generator in case of lack of energy. So because these are usually for small household applications or for small communication applications, so usually this backup is not really common at this particular power level. But if the criticality of the situation demands and if the economics works in favor of that, then genset type of thing might also be available. And if we want to automate that operation of the genset, then that start-stop command should also be managed by the controller, as we can see in this particular block diagram. So this is the second level of our standalone PV system. And then coming to the last category in the standalone PV system, what we can call as the high power standalone PV system. But please understand that this high power here is not with respect to the grid. It's only with respect to the smaller applications, the remote applications where the grid is not available. So that's why here high power basically means anything above 2 kilowatt peak, which is actually, I mean, in terms of grid, it is nothing, but for remote locations, that becomes significant for remote applications. So here, as we see, there is the major difference is basically in terms of the control, which has been now split. So far there was only one control block there, and the controller was unified. But here, what we usually propose, or the systems which are proposed at this power level, is that there is a separate charge controller which monitors the operation of the MPPT, and the battery, that interaction. And usually it comes as a solar charger module. And then there is a discharge control which deals with the interfacing of the loads and the battery. And because we are talking about 2 kilowatt peak and above power levels, so usually we understand at this power level, usually the loads will be AC. So invariably you will have an inverter also being a part of this system. So this sort of is the complete standalone PV system, which has all the components of a standard standalone PV system. And as we said, these may be standalone systems of 2 kilowatt peak to several dozens of kilowatt peak. That will be the type of power range we are talking about. Then such installations generally use one or several solar chargers equipped with MPPT converters and DC-AC battery inverters. So as we see, there is a solar charger thing which has the MPPT tracking function and also the charge controller for ensuring that the battery is getting the power at the designated voltage level, and also your maximum power point is being tracked. And on the other side, there is this DC to AC inverter with a discharge control mechanism, which ensures that the battery is not drained beyond the depth of discharge recommended level. So that type of two-level control would be needed here. And so the controller is not a single device anymore. The charging control is usually ensured by the solar charger. Sometimes several chargers might be, solar chargers might be needed in parallel. And the discharge control is monitored by the inverter. And the inverter should also manage the backup generator, if any. So, because this thing, the backup generator has to do with the interfacing of the loads with the battery. So if the inverter must be able to sense whatever is the demand level, and if that is not being satisfied, then the genset should be put on. So this is the third level of our standalone PV system. So before we move ahead now, so this is like some basic fundamentals. I think being faculty members, I think everyone must be aware, but just for revision, or maybe because people from different backgrounds are there, different branches of engineering. So just to bring everyone on the same page, we had this small discussion. Now, before we go to the next part, which is actually the hands-on for the standalone PV systems, I would like to have any inputs if anyone is having, or any questions. So we can just enable the I'm enabling the attendees to unmute. So if you have any inputs or questions or any comments so far.
Good morning, sir. I am Dr. Jnanamurthy, Anna Institute, Campus, Tamil Nadu.
Yes, sir. Your voice is really low. Is it possible to have?
Yes. Now is okay, sir?
Yeah, somewhat. Okay. Okay. I'll try.
Hello?
Yeah, please. Yeah, please go ahead. Yeah.
Sir, if the solar PV voltage is not current, and voltage is continuously it will be same or it will be different, sir? How it will be managed? The fluctuation of voltage and current depend on the sun it will be variable. How it will be managed? What way they will be controlled?
What I could make out, I mean, it's not really very clear, but what I could make out is that probably you're saying how we will manage the fluctuation of voltage and current.
Yes, sir. Yes, sir. Yes, sir.
Yeah, so you're talking about the fluctuation in the operating voltage and current due to the MPPT?
Yes, the operating voltage, which one is controlled? The monitoring that to sending the voltage or current to be uniform to the systems.
Yeah, so as we understand, see the current and voltage output, mainly the current is highly dependent on the irradiation. So as the irradiation changes, I mean, and we are having MPPT tracking things, so this voltage and current operating point will change. But what we want to ensure is that if you talk about this, the standard standalone PV system, the last one which we looked at. So in that case, as we understand, so as we understand in this case is that there are two things here. One is that your battery needs to be charged at a constant voltage level. So this particular, the charge controller will ensure that interfacing, that even if your PV array voltage and current is fluctuating due to the MPPT and the radiation variation, the charge controller will ensure that the power fed to the battery is at the constant voltage level. And on the other side here, you have, now this is more or less steady because the battery output voltage typically is steady with a small droop maybe. And then you have the inverter here, which converts the DC power output of the battery to a suitable form, the AC conversion for the user loads. So the inverters are very standard and they have a lot of, inbuilt features to ensure that the voltage and current profile is close to sinusoidal and suitable for the AC loads. So that is how, at the two levels, we will ensure that even if there is a fluctuation in the PV output, doesn't impact the load or the battery that way.
So what is?
Thank you, sir.
Yeah. Other input or question? Oh, my volume. Yeah. Yeah, please go ahead.
So what is the full form of MPPT?
MPPT is maximum power point tracking.
Maximum
tracking.
Power tracking. Okay.
Yeah.
Thank you.
Maximum power point tracking, as I have mentioned here. Achha, I didn't mention. I'm sorry. Yeah. So maximum power point tracking, MPPT. I think it was mentioned here. Yeah. This is the full form of MPPT. Okay. Any other comments, inputs, questions? Okay, so let's move ahead. Something.
Sir, what actually MPPT does, sir? Hello?
Yeah, sorry.
What actually MPPT does?
MPPT ensures that the voltage and the current output is of your operating point of your PV system is at its peak, at the peak maximum power point output. So let me just try and make something here. So as we understand that we have, let's say this is a rough IV characteristic. So we have the current here, I, and we have the voltage here. So as we understand that not really that way, not that sharp, but something of this sort. is the IV characteristic. So now depending upon where we are having the operating point, suppose if my operating point of the PV system is at this point, so the voltage I'm operating is here at this level and current I'm operating at it is this level. So the power output of this, because it's a DC system, the PV array, so the power output will be voltage into the current, which will be basically the area under this rectangle. So I'll be having only this useful power output. Whereas, accordingly, if we define different operating points, this particular thing will change. So what has been observed is that the maximum power point occurs somewhere here around the inflection point where the curve is changing its slope in a very rapid way. So this let's say is the maximum power point or the MPP, which is defined as many times. So at this case, you have the voltage operating voltage here, and you have the operating current level at this level. We call this as the VMPP, the voltage at the maximum power point. So this is the voltage at the maximum power point, and this one is the IMPP, which is the current at the maximum power point. So same way we call this as the IMPP. So as we understand now, this particular thing gives me the the highest power output or the maximum power output for the given IV characteristic. So that is like for one steady IV characteristic. Now what will happen is that, as Professor Saini was also discussing, that actually this IV characteristic is not steady if your current irradiation and temperature varies. So typically, if let's say the irradiation drops to some value, current is almost directly proportional to that drop. So if let's say this was at some particular X irradiation value, and now the irradiation becomes half, so current output is also, the short circuit current is also almost half. The voltage only drops by some amount maybe. So there is now the maximum operating point will have to be shifted. It will be somewhere here maybe. So this shift, this MPPT algorithm ensures that if your ambient conditions are fluctuating, the operating voltage and current are always at the optimal point or the maximum power point for a given IV characteristic. Okay, does that help?
Thank you. Thank you, sir. Thank you very much.
Thank you. Anything else, or should we move ahead?
Good afternoon, sir.
Yeah.
Thank you very much to provide this opportunity to ask a question. Sir, if characteristics of solar cell is changed, maybe like PV polycrystalline or monocrystalline, maybe tandem or disynthesized. So
Right.
MPPT setting is completely changed.
Yeah, so it will depend. Actually, there are very true, very nicely you pointed out. Actually, there are different types of materials, solar cell materials, and they'll have different IV characteristics. Very correctly pointed out. Now, this will depend upon the type of MPPT algorithm, how it is basically what inputs it is taking for sensing that particular change. So most of these are like the perturb and observe type of algorithms, which see that if there is a perturbation, then which way your operating point is shifting. So that way, the algorithm control basically needs to be defined appropriately for suiting the given IV characteristics. And there is a lot of research actually going on that also, on having more better and better IV characters, the better MPPT algorithms. And as you rightly pointed out, that solar, this silicon polycrystalline or even monocrystalline, that is almost saturated, and we have well-defined MPPT algorithms for those. But for the new upcoming technologies, so if you have dye-sensitized solar cells or perovskite solar cells or now the upcoming organic solar cells and all, so for them actually there is a lot of scope, and we need to have better MPPT algorithms which can suit those IV characteristics. Yeah, that room is open for research actually.
Okay, thank you very much, sir.
Yeah. Okay, thank you so much. So, should we move ahead, or any more inputs or questions? Okay, then let's move ahead because, yeah, is there something else? Okay, so let's move ahead, and so this was just like one basic introduction to this thing. Now let's actually go to the hands-on part of this and see how we can implement this thing in PVSyst. Basically the PVSyst is a software which can be used for the sizing, also sizing of the PV system and doing some initial analysis. And also there are a lot of advanced features also So as we go ahead, we look at those and we can really simulate the system, PV system, the entire system operation in this in a very good way. So this is the initial interface which you will come across with PVSyst when you open it. I have also, right now I'm also having the demo version only, so the trial version. So I've opened this here and this is what we actually get. And this is very upgraded one. Actually, this is PVSyst 7.0 and they have really changed the interface in this in a very significant way. Till the previous versions like 6.1, 6.2, 3, 4, like a lot of versions they released over last few years. So the overall look of the software was almost same, but this one, the latest one, PVSyst 7.0, it has got a very revised and very professional look. Actually, this is really good. And if those who have worked with this in earlier versions, like I started working on this software, I think around 2012. When I was starting with my PhD. So that time it was very crude, so to say, and also it used to crash very frequently. But now, I mean, I've been trying this new one version for last few days. This is really good and has a lot of new capabilities and doesn't crash also that frequently. I mean, it has not crashed so far in the last week or so. Whereas the earlier one we used to crash very frequently that way. So this is a good one. So and in this, if you open, you'll see this initial interface. So here there are different options and we can do simulation for a grid connected system, a standalone and a pumping system. By the way, there is another option here which is preliminary design. So this is the project interface. If you open the software, I hope this is what opens. Okay, or let me, because I didn't really, let's just open it from beginning and see what type of interface everyone is getting. Because many times it just, in earlier versions, it used to ask if you want to go to preliminary or project design. So that's interesting. So now what we are having here is you see that this is, it straight away goes to the project design. In earlier versions of PVSyst, if someone is having earlier version, you will see that it will open another, before this window comes, or this type of interface comes, there will be another interface which will ask whether you want to have project design or preliminary design or those type of things. Now it is going directly to the project design, and whereas preliminary design is also possible. So preliminary design is very simplistic and we'll not go into that much because it is like very crude and simplistic thing. We'll directly go to the project design. And let's start with the standalone project design. So we'll click on the standalone thing and you will get this type of interface. So you can also try it if you have two separate systems. Probably, I mean, on one you can have the video of this thing, and on another system you can try the, or maybe your mobile one, you can put the video of this session on the mobile, and in your laptop or desktop you can have open the software, because we'll be doing few things and you can simultaneously catch up with that. So I'll wait maybe just a minute or so. Everyone, I hope people are able to, they have downloaded and they're able to open and come to this particular page, project interface, and then the side, the standalone thing. Okay, so now let's create a new project in this. I had created some earlier one. So this is what you will get when you don't have any existing project and you open a new project. And right now we are talking about the standalone system only. So this is the type of interface you will get. And here, as you see, there are a few things which need to be defined. Okay, simultaneously we'll look at this also, so that you know this, because these slides I'll be sharing with you. So once you are, I mean, later on also you can revise this and have a look at this. So if you want, before we go ahead, just let me give you a brief. What are the steps involved in this development of a project or a standalone PV project in this PVSyst? So first is that you create a project by specifying the geographical location and the meteorological data. That will be the first step. Then we define a basic system variant, including only the orientation of the PV modules, the required power or available area, and the type of PV modules and inverters that you would like to use. And also some of the other things, the user needs and all. Yeah.
Hello.
Yeah.
Sorry, sir. We are unable to see the screen, sir.
I have shared that, I think. What about others? Others are able to see?
It is showing high power standalone.
Yes, sir, it is visible.
It is showing.
Yeah, because I've shared the entire screen. I've not shared any particular software. So I think whatever I'm opening should be visible, I guess. Sir, you can please maybe check the connection at your end, or just log out and leave the meeting and join again. Sometimes those issues are resolved by that also.
Sir, sorry for interruption.
Yeah.
Sir, actually, I'm having a lecture around 12:30. So afterwards, can I join so that hands-on practice I can be able to do one of
Yeah,
PVSyst
sure.
software?
Yeah, sure, no problem.
Okay, thanks. Yeah.
Yeah. Okay, so what? Yeah. So I'll just mute everyone probably, and then we'll unmute when we need that. So what we'll do here is that the first thing when we're talking about the standalone PV system, the first thing is that you need to define the site and the meteorological input of the project. That is a very important, the first step. So how we do this, I'll just demonstrate, and then we'll take questions on this if needed. So as you see, when you open this type of an interface, this is the first opening interface. And here the project's name is there. If you want, you can give a name, a suitable new project, or whatever, suppose I want to give it the name of hands-on session 1. Suppose I give this name. Now the site file I need to select. So which is the geographical location where I Kanpur. So this is okay. I accept the selected point. And now what you see is this. It has got Kanpur here, country India, region Asia, the latitude and longitude, altitude, time zone, all those data are already there. Then this is important here on the right hand side. If you see the meteor data import. So there are actually 4 different meteorological databases which they have provided as options. And we can choose which one of them we want to take. The default for PVSyst is this meteor norm. And this meteor norm basically is a software application which has been developed in Europe, and they provide this one. So this is the meteor norm software website, and it's mainly, yeah.
Sorry to interrupt. Like, I'm getting comments from a lot of people that the screen has been fixed. So it might be worthwhile to reshare the screen, since a lot of them are getting this trouble. Yeah.
Okay, I'll do that again. Yeah, please you tell me about the comments, because I'm not able to see the that comments thing really.
Sure.
Yeah. So now is it visible? I have reshared it.
Yeah, people can comment.
Okay, maybe I'll just enable the thing here, unmute and speak out.
Yes, sir. Now it is changing.
Oh, it's already allowed. Okay,
Hello?
That's good. Yeah.
Sir, can you
it's
please
changing.
restart from where the site selection is there?
Okay.
Sir, due to network issue, we are unable to see it, sir. Can you restart from starting, sir? From the geography.
Sure. So this is okay, right? This so far you can see this screen, right? Where I have a new project and I put a name for the project.
Yes,
Sir,
yes.
still Teams software is open.
Oh, that's very PVSyst software.
It was open. Sir.
Yeah, we have open.
Now, are you able to see the PVSyst window?
Yes, sir.
Okay, that's good. So
Hello?
now, yes, ma'am.
Hello, sir. Actually, I had been trying with the PVSyst software along with the simultaneously, but the thing is that for twice, actually, it just went. The program just stopped responding. Software. I mean, when I'm trying to go to the site selection that you just told right now, I have entered the meteor file option, that is location like Bombay, Juhu. But the moment I try to open the site selection, it's after a certain amount of time, it's saying that the software is not responding. So I mean, it's closing automatically. So is there any problem in the installation or?
No, are you using PVSyst 7.0?
Yes, sir. The one that you had given in the chat box that I had downloaded. But
Okay.
actually, twice I am seeing that it's not responding. I had
There
when I
might,
hit the new site, I'm
yeah, no,
telling you, the message that is showing no hourly meteo files available in the vicinity within 10 kilometers. Synthetic hourly file will be created for the chosen site when saving the project. Uh,
mhm.
you can increase the research radius in the project setting
Oh,
or
so
import a
then,
meteo
yeah, it
file.
might be that it has not downloaded. I mean, all the libraries are not maybe downloaded. That might be a possibility.
Okay,
So it's
okay,
not
okay. That
crashing,
is
right?
why.
The system is
So
not crashing,
I
right? The software is not crashing, right?
the software stopped automatically twice. That is why. Shall I exit the software and start once again?
Yeah, you can exit and start again. And also, ma'am, there might be a configuration of your system. I mean, it is a quite heavier software, so it needs a good sized
Oh,
RAM actually. That also might be one case.
oh no, because
So
my laptop, suppose, it has 4 GB RAM. Does it need more than that?
no, 4 GB is good. 4 GB is good. I think that might
Okay,
not be an issue
okay.
then. Yeah, yeah.
But I think there is the issue is with the software. I think it's perhaps
Maybe.
database.
Yeah, that is a possibility. Yeah, right. Very true.
Okay,
Yeah. So,
okay, sir.
okay, yeah. So let's. So I'll just repeat that thing again, the site selection part, and so yeah. So as you see here, there is this option of this new site, this green plus sign, and when you click on this new site, you get another dialog box of this type. You get this world map, and by default it is going to Geneva, the headquarters of PVSyst software company. And we can, I mean, locality search is also available, but I find that this map thing is quite easy and handy to use. So that is, I always prefer this option. So as we said, we wanted to take Kanpur here. So I am zooming into Kanpur here and selecting this place. So as you see, now it is showing some other locality, Sirsa Mau, because there are a lot of. I mean, it takes usually by a 10 kilometer by 10 kilometer grid. So there are different localities which are there and for which the data might be available. Now you see here, I've selected this and it is showing Kanpur in the locality here on the right hand side, and some the geographical location data, latitude, longitude, altitude, etc. are given. And now I accept the selected point because that is what I want. Okay, so everyone so far good enough? Any problems so far?
No, sir.
Okay. So now we got this one, and we got the Kanpur location and the geographical locations. Now suppose on the right hand side, this was what I was discussing, is that there are 4 types of meteorological data options which are available. The default for PVSyst is Meteonorm 7.3, the latest version. And so I was just showing that Meteonorm is this particular, has got this website. It's basically a software designed in Europe, and they provide data for across the globe. And so this PVSyst has this inbuilt data import from Meteonorm, and that they take as the default meteorological file. So if you want to have this Meteonorm thing, you can import it here. And as you click on import, so as you click on import, you will see this type of a window will be populated with the data here. So basically the GHI values, the global horizontal irradiation for Kanpur in kilowatt hour per meter square per month. Then you have horizontal diffuse irradiation. And if you have global and horizontal, obviously direct normal can be estimated. Along with that, you have temperature, average temperature, monthly average temperature, wind velocity, the turbidity factor, and the relative humidity. So all these are there in the meteonorm database and they become available here. Also, if you want to change the irradiation units on the right hand side here, you can change that also. Kilowatt hour per meter square per day, or different other units are also available. Most common is either kilowatt hour per meter square per day or per month, because we are talking about electrical output. So kilowatt hour is in the same energy units. So this is what we get here. Now everyone got so far, right?
Yes, sir. Yes.
Okay.
Yes, sir.
Okay. So now we want to import this data into our PVSyst software.
Excuse me,
So
sir.
yes, ma'am, please.
Hello.
Yeah.
Sir, can you please, actually I have restarted the software. Can you please tell which location have you chosen? Which geographical site have you chosen, sir?
Yeah, I've just chosen Kanpur here. So you can go on the map of India and select
Kanpur.
this Kanpur location.
Sir, in the geographical site, in the scroll down menu, I've chosen India. And after that, all the locations are coming from Ahmedabad, Bombay, Calcutta,
No,
Jodhpur,
you can
Madras,
go by
Gonda.
this one. You can go by this green plus sign here. You can click this one, new site.
Okay, sir. Okay.
And
Okay.
yeah, you go to the new site and you get this world map. And then you go to whichever location you want, just pinpoint to that location and select that one.
Okay, thank you, sir.
Okay. So this was our location which we took. You can take any location for that matter. I just took one random example. Okay, so we accepted this one and we chose meteonorm to import. And this was the interface which we got. So, but right now it is showing on your screen and it is there. I mean, it has got the access to that database, that meteonorm file of Kanpur, but that data is still not there for the simulation purpose. To do that, you need to do two steps. First is that at the bottom here, you see export table. Okay, so just click on this export table button. And it says the full monthly meteor data is now copied into the clipboard. You can paste them in Excel or any other spreadsheet program. So if you want to see that data, the entire data in or put it in an Excel format, then you can do that also. Or basically we just want to import it to the software. So after you have done the export table, just click on import. And it will say data for Kanpur imported with success. Okay. So now the data for Kanpur has been loaded in the PVSyst software and we can use it for the simulation purpose. Okay, any questions so far? I think this is clear.
Yes, sir. Clear.
Okay.
So my software is not supporting. It is asking the directory.
Yeah, so there might be some installation problem, please, you need to reinstall it actually. So,
Okay.
Yeah.
Hello.
Yeah.
Yes, sir. Actually, I select my city and I got the import. Then after that, in your screen, there's a data from Kanpur imported with success. How this message came?
Yeah, so that's what I was saying. First, you click on this export table button at the bottom.
Yes.
Now the data will be exported, copied into the clipboard. And then after that, you click import. If you just click import directly, it will say data is not available. Okay. So first export table, then import, and then the data will be loaded. Okay.
Yes, sir. Thank you, sir.
Okay. So once you have got this data in your software, now you can save this one. And as you see, if you click OK, it will be automatically saving this. So just click here, bottom right corner, click OK, and it will it will save it as a new file. And the extension by default is SIT for a site. It is .SIT because it's a new site you are defining. And the file format is MN73 is meteonorm 7.3. If you want, you can change this, but I would recommend that keep it in this format only, because you have the name of the city underscore which type of database you are using, Meteonorm 7.3, so MN73, and just save it. So it will be the geographical site file Kanpur underscore MN73.sit is now saved in the database. So this is saved. And further, it will ask you that a synthetic hourly Meteo file has also been generated. Do you want to save it? So there are two files, please remember. One is the geographical site file, which we have just now saved. Another is the Meteo file. So you just say yes to this also. And this also, they have a default naming format for that, Kanpur MN73 underscore Singh. So this is the synthetic Meteo file. So basically what they will do is that they have basically sampled the data over the year, and now they will create a synthetic file which will have the data for all the hours across the year. And then you save it here also. So both are saved, and you see now the site file is also same. The site location for Kanpur is showing as the site file, and Meteo file is also the Kanpur Meteo file. Okay, same way, all of you, whichever location you select, you'll get the site file and the Meteo file for that location. Okay, and here also there is one message for me also, that no hourly Meteo files available in the vicinity within 10 km. A synthetic hourly file will be created for the chosen site when saving the project. You can increase research radius on the project settings or import a Meteo file by using Meteo database. So in case there is no file nearby, that will, it will create a synthetic hourly file depending upon whichever is the nearest location. And by the way, this is a warning. The orange messages are warning, so I can ignore and move ahead also. Or if I want to change, then I need to look for another location. So basically the data for around this location is not really available maybe. So I can shift my point in close vicinity and see if there is a nearby, because it's a 10 km by 10 km grid in which we are is not yet ready for simulation. Additional input is required. So you see in the variant box, the orientation and users needs, these are shown in red color. And here also you have this message in red color, the orientation is not defined. So you cannot move ahead before you do that. That is the intent, and that is the why it is given in red. So the first step now, before we go ahead for defining the variant, is the defining the orientation. Okay, so let's click on this orientation button and you'll get this type of a dialog box. Everyone has got that?
Sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So now let's look at the next step, what to do here. So this is the dialog box we got here. And let's see some things which we can do with the orientation. So this is a tool aimed at showing the best suited orientation for a PV system, or what you lose when when not optimally oriented. Okay, so there are different orientations which are possible. By the way, you can look at this field type, and at the top you have this drop down menu. So there are different options which are available, and broadly speaking, there are three categories. One is the fixed orientation planes, then you have single axis tracking planes, and also you have two axis tracking planes. As we know these days, mainly we are going for fixed orientation planes, and because of the overall system economics works in favor of the fixed orientation planes. So that's why the fixed tilt plane always comes as the default. If you want, you can choose a different option also. Like for example, suppose you choose seasonal tilt adjustment. Then what will happen is that you can put two different values, a summer tilt value and a winter tilt value. That means in summer seasons, and you can also choose what are the summer and winter months, their definition. So for like here in summer tilt, there is one particular value for these 6 months, winter tilt for other 6 months, a different value. Also the azimuth also you can change. Okay, so that way you can define. And I mean, we conducted some study during my PhD. We looked at the effect of this two tilt system for Mumbai as the location. So we saw there was around a minor gain for, again, it depends upon the location, what type of profile, irradiation profile is there, how much is diffused component, how much is the direct component. Based on that, the gain might be different. But for Mumbai, we found that it was not very high, around 2% in that range. That if we choose different tilts for only two values, one for summer, another for winter, then and we varied it in a 20-degree range. So like we know, the default value for a tilt is the latitude of the location. That is the like taken as the thumb rule. So what we defined was that Mumbai latitude was 19 degree, is 19 degree. So we defined two tilts. One is that in the summer, we tilted at, let's say, your particular value slightly higher, and one was slightly higher, another was slightly lower. So 9 degree and 29 degree, we defined that way. And we found that 2% variation was coming. So that way, if someone is interested, they can do this seasonal tilt adjustment also. But the default is the fixed tilt plane. That is the default one here. And in the fixed tilt, you can define the tilt angle. And as you see, this is coming out to be 30 degree, but we can always change that. So the thumb rule is that it should be same as the latitude of the place. That is the thumb rule which people recommend. And so I can always adjust this one here. I can change this thing here. And if and another thing, there are few more orientations also possible, like you have unlimited shades. So if you are having, you don't want any shading on your thing, because there usually we take that on 22nd December there should not be a shading before 3 p.m. of that sort of rule. But if you want that across the year there should be no shading, then there is another things you can define the pitch, and the separation between the panels will basically increase, because you don't want any shading across the year that way. So those things, those options are also there. There is one option of sun shields. So if you have them vertically spaced, typically a building integrated PV type of scenario, then you can do this. Or then there are options for single axis tracking planes. So you need to define the tracking parameter and the tracker characteristics, and the electrical efficiency and all, and electrical effect in the simulation, how much is expected. So those things are for a 2-axis plane. You can define how much will be the minimum and maximum tilt and minimum and maximum azimuth. So all those options are there for other cases. But the default, as we know, is the fixed tilt, and because the cost of panels has gone down really in a big way, so the economics actually at present always works out in favor of the fixed tilt panels only. So this is the fixed tilt panel which we are having. And in this fixed tilt panel, so let's say in this project we go ahead with the fixed tilt panel, and you can always adjust the tilt and azimuth. Azimuth we always take facing south, if as far as possible, until unless there is some obstruction in the south. So that is shown here as azimuth 0 degree. And the plane tilt you can always change. It's always advisable to go as per the latitude of the place. So if you want to make sure, you can always check also what is the latitude of the place which you have selected. So you can have a look at this and see. So you see the Kanpur, the latitude of the place is 26.46 degree. So 30 is also a good approximation, not much issue with that, but we can always fine tune it also. So let's say I take this as 26 degree only. Azimuth I keep at 0 degree only. And then there are 3 options here. Optimization with respect to yearly irradiation yield, another is for summer, third is for winter. So what is the idea here is that, now before we go to that optimization thing, there is one thing we need to understand here. There is something known as the transposition factor and loss with respect to optimum. So whatever is the optimum output, how much you are losing with respect to that. And you'll see when you choose these different options, this value will change. Like for winter, it is saying loss with respect to optimum is minus 2%. So you'll be losing 2% of overall annual output if you optimize for winter. If you optimize for summer, the loss is minus 1.6%. And if you optimize for yearly irradiation yield, so then that is the optimal actually. That is the maximum output you'll get. So, but it might depend. If someone is, let's say they want the PV output for a particular type of application, let's say for heating in winters or some particular application in winter months, then they might optimize for winter. Or if someone needs mainly for summer months, then they might optimize that way also. There is a minor loss, like 1.6% in one case, 2% in another case. But the year-round optimal is for the yearly irradiation yield, and that is the optimal point. And another thing is the transposition factor. So let's look at this definition. Transposition factor is the ratio of the incident irradiation on the plane to the horizontal irradiation. That is what you gain or lose when tilting the collector plane, because the data is available for horizontal locations, So because as we see, when you were, okay, I'll not go into that again, but it will take time. But if you recall, when we were importing the data, there was global horizontal irradiation and horizontal diffused irradiation. So the data files which are available from any of these databases, they provide you the horizontal irradiation, either global or diffused. And transposition factor says that what is the effect of tilting? So by tilting, how much are you gaining with respect to the horizontal value? So like we fixed it at 26, and I said in this case, so yearly irradiation yield is 1.09. That means if I put the panel horizontally as compared to that, if I tilt it at 26 degree, 9% is the gain. And same way I can see in all the cases, actually usually you'll see the transposition factor is same because you're not changing the angle, but the overall annual energy is you might be losing out in one of these cases. So overall we see the overall maximum is for your yearly irradiation, and you have got a transposition factor of 1.09, and this transposition factor can change if you change the plane tilt and the orientation. So accordingly, the graphs here on the right hand side, they show that thing. So azimuth 0 degree or south facing, you get the maximum output. But if you change the orientation, there will be a minor loss in the transposition factor. Okay, so it might you might decrease from 1.09 to some other value. Same way, the plane tilt is coming around maximum at this 26 degree, and if you change the tilt on either side, then the transposition factor will be somewhat lower. So those are the informations here. So the default usually is that, to summarize, we take azimuth at 0 degree for south facing, plane tilt same as latitude of the place, that's the thumb rule, and yearly irradiation yield optimization for the best output across the year. Okay, so with these three settings, we click OK here, and now this orientation becomes green. Okay, any questions so far? Okay, so now we have defined the orientation of our, so we have got the site.
Sir, as you said that according to a geographical location, we have to select a tilt angle.
Right,
so
right.
How we can get to know that this should be approximate, like if I have selected 25 or 22 degree?
Yeah.
How I can come to know that this is a suitable angle?
Yeah, so actually there have been many research studies in the past. I mean, this is actually quite settled issue now. So there have been a lot of studies, and people have found that if you want to optimize the year-round output, then take the tilt of the PV panel same as the latitude of the place. That gives the best result actually. At least in the tropical region, that is for sure. We might not, I mean, at a very high latitude, it might change. That might be a possibility. But the zone in which India is located, in this zone, that is always the, I mean, you can do the simulation and you can check for yourself also. You'll see that that is the standard result, which is accepted now as a thumb rule.
Okay.
So we just take it same as the latitude of the place to optimize the year-round output.
Okay.
Okay, so we got the orientation now, and now next thing, as you see the message here, is that users needs not defined. With a standalone system, you have to define the valid or non-zero users needs. So users needs now need to be defined. Let's go to that here. What does that involve? So, okay, let's look at this. You need to complete the table of daily consumption. So let's click on users needs, and this is needed for a standalone PV system because you are designing for a given application. Okay, it's not for given end use. So it's not for because in grid connected system this will not be the case. In grid connected system it's not for a given end use. You can generate any amount depending upon the availability of land and the economic and the resources, the financial resources. But in this case, for a standalone, as Professor Saini was also mentioning, that for a standalone cases, we always want to, we need to define it with respect to our needs. So when you click on users needs, you will have this type of a dialog box. And here you can define the daily consumption. So
ना मोर पटो आम पटो म्यूट अब हां को
yeah, the users can the participants can please mute themselves, those who are I mean, if because it's disturbing the others. Only when you have a question, please
Hello.
unmute yourself and speak.
Dr. Rhythm.
Yeah.
I'm not having that option of users need. I'm having the option of system.
Because you went into grid connected system. That is the reason.
In
the first step, you choose the standalone system, then you get this.
ଭାତ ବି ଗୋଟେ ଏକ୍ସଟ୍ରା ମଗେଇଛି ଆଉ ଚିକେନ ଥାଳି ଗୋଟେ ଏକ୍ସଟ୍ରା ମଗେଇଛି ନା ଖାଇଦେବି ତାଙ୍କର
Nakulji, please
ଅଣ୍ଡା
mute
ଖାଇବ ସାଧା
yourself.
ଗୋଟେ
Nakulji, please mute yourself.
So I'm not getting the Nagpur data.
Sorry. Yeah, was there some question? Okay, so now what we are having here is that this is the daily consumption. Yeah. Yes.
Mute.
Okay. Okay, so we get this thing, this dialog box for the standalone system. We need to define the user's needs. And as you can see, different appliances, some of the common appliances are listed here, and it's very user friendly that way. You can just choose the number of devices. So suppose first is the lamps or LED or fluorescent, whatever lamp one is having. So suppose I put some number. Suppose I have got 4 lamps, LED lamps, and the power rating for each, suppose 7-watt lamp I am having, and the daily usage. Now let's say I put some number here also. So I have suppose 5 hours of per day usage. So it will do the calculation. Same way I do for the other things also. So suppose I have got 1 TV and 1 PC. So I put 2 here, TV, PC, mobile, etc. is here. And let's say this is consuming some 50 watts per appliance. And I'm using, let's say again, for some 4 hours each day for each appliance. And the same way, there are different options: cloth washer, dishwasher, fridge, domestic appliances, some other uses you have. So some of those common things are listed. Suppose let's say some numbers here. Suppose I have 3 other domestic appliances, and the average power rating for them is, let's say, something 60 watts or something. And I'm using, let's say, from them for 3 hours per day. So I put that also here. And then the only thing you difference is for the different thing is for the fridge actually. So for fridge, suppose I have one fridge. For fridge, they have somehow put it because usually the fridge will be operational for 24 hours every day. We don't switch it on and off. So that's why here the daily use is given in kilowatt hour per day instead of the power rating, and 24 hours is given as the default. So most of these fridges these days, they are quite energy efficient. So let's say some value, suppose suppose something, usually in the tune of around 1 kilowatt hour per day, or that range is what they consume. A medium-sized fridge for a domestic application. Suppose I put something 1.2 kilowatt hour per day. So I got that also. Okay, and so that way we can fill up this table with respect to the appliances which we have. And there is some standby consumer here because many of these devices, even in the standby mode, there is a very small power consumption which they have. So you can see that PVSyst has added 24 watts or on 24 hours a day. That means 1 watt thing for standby consumers. So when your devices are off, very often a standby or other lamps remains on. It is therefore necessary to define this consumption in order to achieve a dimensioning closest to the reality. So they have defined some standby thing also. You can, if you want, you can change this also, by the way. So how much is the power you expect your devices to draw on standby, and you can accordingly put some value, usually very low value. So suppose 2 watt, and then standby will be there for 24 hours. So accordingly some value coming here. And if you want to add more appliances, that can be done. So you got this here. And now once you've got, you see there is in the bottom right, there is one message in red. Appliance number 1, please define the hourly distribution on the second page. So far you defined that, okay, how many appliances you're having, what is their power rating, and for how many hours you'll use. But because we know that PV is a temporal variation, it has got a temporal variation. It's available not throughout the day, rather only in the sunshine hours. So when this usage occurs, accordingly, it will be having an impact on the sizing of the system, whether we want to size for a larger PV panel or for more battery usage, that would be changing. So this, and also to complete the load profile, we need the information, not only the time, but also when this load is occurring. So you need to define the hourly distribution. So you go to this hourly distribution, second tab here, just next to consumption, you have hourly distribution. You can click on this and you'll get this type of dialog box. Everyone so far, is it okay? Everyone has been able to come this far?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Yes,
okay.
sir.
Okay. So now let's look at this. What is this thing, and what is this hourly thing? So now that you have defined the devices and their power, you must enter the operating time slots for these devices. It is important that these time slots are correctly completed, because it is with these elements that the sizing of the PV field and the battery pack will be calculated by the pre-sizing tool. When you click on the hourly distribution tab, the respective watch dials for your devices will be empty. So as you can see, there is a watch dial type of thing which is there for each device. So we selected these 4 devices here: lamps, TV, domestic appliances, and fridge. So for each one it is there. For fridge, because it's a 24-hour operation, so it is entirely filled. All these time slots are entirely filled already. And this hourly profile which you see in the bottom right is just due to the fridge. And now what it is saying is that each dial is made up of, so only the dial for refrigeration systems will be completed beforehand. But if you want, you can modify that also. So suppose, I mean, usually it doesn't happen. Suppose I want to switch off my fridge for 1 hour or 2 hours. So what you do is that for filling in or filling out of this dial, you need to, if you click left click of your mouse, then this dial becomes filled. Any dial will become filled up. And if you click the right dial, then this will be deleted. Okay, so right click and left click. So if in the fridge, if I want to remove some particular hour, so there are 48 of these, you see. So 24 and into 2 rings. So each ring has got 24. So it's basically half-hour slots. So you can define your load pattern, load profile to a resolution of 30 minutes. And it is starting from 0th hour here. So midnight, 0 hour, then 3 hours, 6 hour, 9 a.m. 12 hour is the 12 noon, and then you have 3 p.m., 6 p.m., 9 p.m. and so on. So suppose, just for example, let's say if I'm saying that my fridge will be off from 6 p.m. to 7 p.m. So what I need to do is that I need to just point to this and right click here. Okay, so during this 1 hour, my fridge will be off. So you see, I just right clicked on these 2 slots, it became empty, and the correspondingly the hourly demand here goes to 0. No, not 0, but the standby thing is still there, that little power of the standby. So, but we'll fill it up by left clicking, because that fridge is usually on there. Okay, so each dial is made up of 48 sections. Each section represents 30 minutes of the day. To define a schedule or a time range, you can do so using the left mouse button. So now for lamps, suppose lamp is, let's say, on after 6 p.m. So I put it on here. The lamps will be on in the evening hours, and let's say they'll be on till so this is 10 p.m. and this is 11 p.m. now. And now one interesting thing, as you can see, is that accordingly this will be updated, because earlier what we defined, okay, we defined 5 hour only earlier also, suppose. So now let's say I change it, I define it 6 hours. So I want to put my lamp on till 12 midnight. So what I see is that now you see it automatically updates here. So this is like a preliminary estimate. The actual thing is the hourly distribution, which can, if you change the hourly distribution, accordingly the consumption data here, it gets automatically adjusted. Same way for TV, let's say sometime in the morning it's on here, and then sometime in the afternoon also it is on here. And then again, so you see, initially for TV and PC we have put 4 hours per day, but if I change it here, it will change automatically. And then let's say sometime in the evening it is on, and I mean you can put half-hour slots also. So like it is so this is 6, 7, 8. So from 8 to 8:30 it is on, then 8:30 to 9 it is off, and then it is becoming on from 9:30 to 10, and then 10:30 to 11, something like that. So that way, accordingly, this value gets adjusted, you see. So the value has been adjusted here. And same way for the domestic appliances, I can define some time range across the day when I'll be using my appliances. So suppose something here, something of that sort. Okay, so that way I've defined, and now I get my hourly profile, load profile. Accordingly, it will change. Okay, so we can define it this way. Okay, any questions so far? Okay, so now we will save this, and this is already there, and everything is in green. There is no error message here, so this is okay. So what we got is that the total daily energy need is 2.78 kilowatt hour per day, or around 2.8 units of energy we are consuming every day. And accordingly, there is a monthly energy thing which we are consuming. So this is the default way of defining this. Then there are some other options also. You can change the consumption definition by, so this is for the entire year, we are defining one pattern. If someone wants, they can define for different seasons also. So let's say this is my pattern in summer, in autumn, winter, and spring, the values will change. So I can change accordingly. I'll define the consumption values and also the hourly distribution values for differently for different seasons. Or if someone wants, they can do it monthly also. So for each month, I can also change. And when I change the month here, so I can choose which month I want to show. So accordingly, month by month, I can change my appliances, their power rating, time of operation, and also the hourly distribution that way. And another option is that, so we'll keep it as years for our case. And then another thing is that it says use only during this many days in a week. That option is also there. So if suppose you want to change here, so by default it is all 7 days in a week. But let's say if I'm going to use this type of a load profile only for 4 days in a week, so I'll change this, and accordingly you'll see this monthly energy changes. Daily energy is same because this we have not changed anything here, but the monthly energy has reduced because now I'm using it only for 4 days in a week. If I drop it further, only 2 days in a week and weekends only I'm using this thing, then accordingly the energy demand drops. But in this case, we'll keep it the default value for 7 days in a week and for across the year. So we got this as the load calculation at the user's end. Okay, and then if we want, we can save it also, by the way. There is a save option. So if you want, you can just click it OK, then it will not save, but it will be there for available for this simulation. But if you want to keep this load profile available for future simulations, then what you need to do is that you need to save this load profile. Okay, so in this case, you can define, you can give a name, file name, hands-on session 1. I'm keeping the same file name as the project name, and I click it save. So now you'll see if I want to load it here, there are some load profiles. So load profiles are given by the extension .lod. So hands-on session 1.lod is the one which I have defined here. Users need domestic users and this one. So same thing comes, So that way, if I save it, this consumption profile pattern can be available for future simulations as well. So we have done that and we click it OK here. Okay, and we will just complete this user's needs before we break for lunch. Is it that okay if I just extend for 5 minutes more? Participants?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Okay.
So we'll just complete this section of users needs so that then we can start with the next step in the next session. So now we defined this one. And this all I think we have discussed, the right clicking and left clicking and all, and you can save it also. This all we have discussed. Another thing is that users need other profile. So there is one more thing if you notice here in this one. If you go to users needs, there is one more button here, other profile. So there is one option that instead of defining it this way, that how many appliances you're having, their power rating, the number of hours of use and the hourly distribution, that is one way of doing it. But there are some other options also, which is known as the other profile. So if you click on this other profile, you will have this type of a dialog box. There are different options available here, like you have fixed constant consumption, monthly values, daily values, probability profiles, household consumers and all. So all these are okay, but the most useful thing here is this one, load values from a CSV or CSV hourly or daily file. So this is actually a very interesting feature which you can use that for importing the data if you have your load data in a CSV file already saved in your system. But for this, you need to have the data in a particular format. So let's just look at this. What is the format here? So the most flexible way for defining a consumer load profile is to input it as an ASCII or a CSV hourly file. The input source file should be prepared in a spreadsheet program like MS Excel in the CSV format. And you can find a template named this one in your systems also. So if you just see, in your when you have installed the PVSyst, you need to go to this location. Wherever you have saved your PVSyst folder, let's say you have saved in C drive program files, PVSyst 7.x in that data RO and like that. So I'll just show you, just demonstrate this, what I mean by this. So like in my system, in the program files, I have this PVSyst 7.0. Okay, C program files, PVSyst 7.0. In this, go to data RO. In data RO, go to PVSyst 7.0 underscore data. And in this, there is this templates file folder. Go to the templates folder, and here is this file. Parameters, params underscore hourly parameter underscore template. Okay, and if you click it open, you'll see this is the template in which you need to define your CSV hourly data profile. So there are whatever lines are starting with hash, those are comments. So PVSyst will not read these lines. Hash is basically comments, and this is also new. It will basically this is the header for this. So it will start reading the data from here. So as you see, this is the format for putting the data here, and there are total each row. There is one row for the power demand of each hour. And total, so there will be 365 plus 24, 8760 hours for the entire year. And the format for each row, for each row entry for each hour is as follows. You have DD, MM, YY. So date, month, and year in 4 digits, and then the hour and the minute, and then the semicolon and the power consumption in watts. So as you see, this is the pattern here. So there are total 8760. Data points for each hour, and you go to the last one here. So as you see, the last one is this 31st December 1990, 2300 hours, 11th, the 12th hour from 11 p.m. to 12 midnight, and the power consumption value 80 watts. Okay, so that way we can define it also. So if we have actual data values, so this gives you a lot of flexibility. You can actually define the entire year's load data, and then that load data you can upload here as the CSV file. You can save it and then proceed with that. Right now we don't have any file of that sort, so I'm not doing this. We are going with our sample data only, which we defined earlier. Okay, so this was about defining the user's needs. So we'll just stop here. Anyone having any questions or anything which so far, anything to be cleared?
Yeah, so when I try to load the CSV file in the PVSyst software, nothing happens.
Yeah, so which file are you loading there?
See, when I go to other profiles and select load values from CSV file and then click on choose CSV file.
Right.
Yeah, nothing happens. There's no window pop-up or anything.
No, in my system it is opening. See, I can browse it for that here. I also clicked that. So choose CSV file, and then you get this thing, and you can browse for this, and wherever you have saved that, you can load that here.
Okay, maybe it's an issue with my system.
Yeah, maybe.
Okay.
Anything else? Yes, sir. After the orientation and users need, the button are green, but the system is showing the message showing that please define the system in red.
Yeah, we'll come to that. That is the next step of this.
Okay.
So we'll come to that after the lunch. Right now we don't have the time for that actually.
So we have to close the PVSyst or open.
Either way, because you already saved it. So when you will try to exit, it will always, I think, prompt you to save this. So you can just save the thing and you can log off. No problem.
Okay. Thank you, sir.
So I'm not getting the Nagpur data.
Okay.
So I choose then Delhi. But still orange color warning is there. So what shall I do?
So you can change the, as I said, there are these 4 options. If meteonorm data is not available, go for either PVGIS or NREL data. NREL database is also good. They have got hourly values for good substantial amount of time. So you can choose the data source. You can change the database.
From where we have to change?
Yeah, I told that. I'll just repeat it again quickly. So you see, when you select this location, or I mean any new location if you choose, so you go to this one here, and this map location, whatever, I'm not changing. Suppose I'm taking this, whatever is coming here, Geneva is coming, so I just go ahead with this. So you see, there are these options which are available. So instead of meteonorm, choose PVGIS maybe. NREL will not be highlighted for Europe because NREL is providing public domain data only for US and India. So that's not available. So in this case, meteonorm or PVGIS is the option, and last option is NASA. So you choose another one. For India, you can choose either PVGIS or NREL, and then do the same procedure.
Sir, hello.
Yeah. Yeah.
Sir,
Please go ahead.
When I am trying to close the this software, it is showing that you are going to lose the work done with the new variant VCO. Are you sure?
So save that. Right. So save that variant. VCO, you need to save VC0. Yeah. Okay. Anything else?
Hello, sir. Where is the save option? Right at the top of the project.
Yeah. So it is there at the top.
Because I have already saved the data several times, but before exiting, I need to click the final save button right at the top.
Yeah, you can do that. And anyways, if you by mistake also, if you click on exit button, it will always prompt you. It will not exit without prompting. Yeah.
So another thing, you showed the load option of the data, that is from where the CSV file can be loaded. Where is the load option, sir?
There, users needs, if you go and you go to other profile, and here there is this option, load values from a CSV or hourly data file. Select this one and choose CSV file.
Oh, okay. So other profile. Okay, sir. Thank you.
Right. Yeah. Okay. Anything else?
Sir, then shall we exit the program for the moment?
Yeah. You can save the variant and exit. We can continue.
It's showing the message file name Kanpur project. Automatically it took, and the description hands-on session 1. So I shall save it in the same name, sir.
Right. With the same name you can save.
Sir, how to save VC0, sir?
It will be saved automatically. You just click save. So that variant will be the default variant there.
Actually, we have done several times, but it is showing same message.
Yeah, I'm also getting the same message,
right? If you just suppose if I change anything here, then probably I'll also get that message. So let me just try. So suppose I'm changing something. Okay, now if I want to exit, it will say this: you are going to lose the work done with the new variant VC0. Are you sure you want to proceed?
Yeah, same message.
This is a warning which it says, and if I say okay, that it actually exits. Right. So I should probably say cancel, right? If I want to save it, probably I should just cancel that warning. So suppose I'm changing this here, and let's say, and one option is that I go and save it here myself. If suppose I accidentally click this exit and it gives me the warning, so I cancel it and then click save. and save it here, and then I exit it. Then there is no problem. Then you can just give OK.
So then also we are, after saving also we are getting the same message. So shall I ignore them?
Yeah, you
the
can go
saving also. Okay.
So after that only the orientation and user needs are going to be resetted, sir. It is going to the red colors.
Okay, there might be one thing because we have not completed the entire thing, so it's not probably because once you, I mean, that might be one possibility. Because usually you see, I mean, we do this thing entirely in one sitting, so I've also not done that breaking in between. So there might be one reason that we are not completing it, we are not running the simulation, and we are just exiting. So it might be the reason that it is not taking it. Yeah, that's what I'm also seeing now.
Okay, sir. Okay, sir. I understand.
So it might be recommended, yeah. Usually because it's a very small thing. Because right now we were just discussing it, so it took a lot of time. But as you'll see, when you do it actually manually or yourself, you do it. This will take very less time. So it's recommended that you do entire thing in one go and then run a simulation, and then I think it will not lose that.
Thank you.
Okay, but in this case also, at least this will be there. The site file and Meteor file will be there. Okay, so let's stop here.
Okay.
Okay, so we will take a break for the lunch, and then 2:30 we will resume our discussion from this point onwards.
Thanks, Professor Rhythm, for such a nice session, and all the participants are requested to join back by 2:30.